This conference will now be recorded.
So any questions from the last class? I know Sukanya, you have sent out the exercises. So everybody, I would encourage everyone to finish up the exercises, the assignments, okay? So that you get to practice those, right? Setting up PyCharm should not be difficult. I know I might have sent out wrong link and all that, but all you have to do is install either Python or Anaconda, then install the IDE, set up the, when you open the project, make sure you choose the Python interpreter, either Python or Anaconda, right? That's all. Then you are set. Create a new project, right? Create a new Python file and start writing program. That should be as simple as that. Okay. And you can always look for videos and all that on the YouTube. Hey, and to install this. There will be tons of videos. Just find out whatever works for you. If you are stuck, okay. It should not be that much a difficult issue. Okay. All right. So that's about Python. And please send out your the assignments and try to complete it. Or if you have any issues, let me know. I'll probably create the Google group tonight based on the this students we have today. Right, that will be our final list of students, and we'll carry on for the next few weeks. Okay, 4 weeks. All right. So today, right, based on what I said in the email, we will talk about the Python was all about giving you a kind of introduction to the language, so that if folks, those who are not they haven't learned Python, or they have not done any Python in the past, or Java, or any language, in fact, right? So you'll get introduced, and that makes it easier for you to learn, right? Somebody introduces you, right? That then you can pick up pretty quickly, rather than you studying yourself. That's always a big headwind, I would say, right? Once you get introduced, then you can carry on its own on your own, right? But the objective was not to make you expert in Python, because I am not even expert in Python, but just to give you, as I said, it's a complementary Python training, so that you get introduced to it and learn the basics, which will be sufficient, or the intermediate level, which will be sufficient to carry on your work. What is needed for this course? Okay, for this course, you need to be able to create simple sample Python programs. That is the whole goal. Yes, it can get very complicated and all that, but at least you can get started how to create a simple program, right? Okay, so that was the goal. So now next today and this week, as well as weekend, probably up to Saturday, right? So I'm not sure when AWS will start, based on or the cloud will start, based on how quickly we finish this thing. I think we are lining up for weekend. If it doesn't complete, we Subham, who is the instructor, he will probably start next Tuesday. If he doesn't, if he completes by Saturday, he may start on Sunday. So we'll see how it goes. Okay, so next topic is big data. Okay, so as I told you, right, apart from Python, which you will practice anyway, right? That you will practice, get good at it. It's not a difficult language, you saw, right? And you couple of weeks of practice will make you better. Now, next thing you need to know, or next thing we are preparing is for be a data engineer, right? So eventually you will become a data engineer on cloud, right? And both whether it's a cloud, AWS or Azure, right? They both require some kind of language expertise, and that's where SQL, and Python we talked about, right? Python, right? But second thing is, what is more, I would say, prevalent in the industry is Spark, okay, or big data technology, right? So that's why we're going to study Hive and Spark. Okay, Spark will cover primarily PySpark, which is Python based Spark. Okay, which is Python based Spark. And that's the reason we did learn Python, so that you can use the Python to build Python-based Spark programs. Hive is the database, and that's where if you have SQL background, you will learn how to deal with Hadoop-based or a big data-based database system, which is Hive, by the way. Okay. Even there are, not everybody is on cloud yet, right? Many companies are still moving to cloud. Many industries or many companies are still have their applications on on-prem, right? We'll talk about that. And they're still migrating. Some are going to stay there. They're not going to eventually go away. Some will eventually stay, right? It's not going. Everything may not go to cloud at some point. There may be hybrid, right? Some data on-prem, some data on cloud. That will always be there. So learning Hive and Spark will not only make you a good AWS engineer, but also become a good big data engineer as well, right? If you want to end up working on-prem, that's okay. You may want to work in a hybrid environment. Every companies have a hybrid environment. So that means you know the on-prem technology as well as you know the cloud technology, right? So there are constant migration between those two, right? They will be there. If you look at the future architecture, it will be hybrid architecture. Okay. So for that reason, we are learning big data. So how many of you have learned know Hadoop or have introduction to or have done anything with Hadoop? Any of you? No one?
No idea for me.
Okay. Anyone from this team has done any? I'm just just the ones who has done it. You can say yes. Otherwise, I will know nobody has it. Okay. All right. Okay. Yeah. So I'm going to send out to, as we do go through the class, I'm send out these documents one by one. Okay. Where did you go? Okay. So we'll do a quick introduction of what big data is or what Hadoop technology is. Then we'll go over the actual. Where did it go? Did you open it? Okay. So all right. Then we'll go to the deeper and deeper. Okay. Next few today, tomorrow, day after tomorrow, then probably weekend. I think we should be able to cover all this Hive and Spark, those two topics, which we in fact require to be for this course. We need those two. In fact, all you need is PySpark, but the reason we are learning Hive is as a database. And if you end up by any chance working on-prem, knowledge of Hive will be good. That's the reason we are learning Hive as well to some extent. Okay, so what is big data, right? Let's think about, right? I'm not going to just think about all of you or many of you probably have worked on IT, right? Not for many years the way I have worked. Maybe even Arshad has worked for many years. So maybe some of you, right? So if you think about 90s or even beyond, right? There were all, what did you have that time, right? They have what I'm talking about the history, right? Okay, history of big data. So if you look at the 90s or even beyond, right, 80 something, right? So we had mostly mainframe systems, right? So mainframe systems. During the 90s, the mainframe used to be a huge platform where you have all these, what do you call green line. I don't know. I see. I'm not a mainframe guy, but it's a gigantic platforms which can manage your applications, whether it's a sales, inventory, all that, right? And you need to know COBOL, copybook, this, that, all that stuff, right? So huge machine, and even until now, many companies are managing their applications, very complex applications in mainframe. They're pretty robust, by the way. They're pretty robust, but it's very inflexible. Very, I would say the language is not that easy to learn and all that. I don't know, but I have seen COBOL and all that. It sounds difficult to me anyway. So, but anyway, so mainframe still big companies. I know companies like even Neiman Marcus and all that, and other companies, right? Some of their large companies are still managing their operational system in mainframe. Okay, so mainframe, we thought by 2000, when Y2K happened, all the mainframe will go out, but that never happened. It is still there. So then what happened? After mainframe, we got into relational databases, RDBMS, right? Relational databases came in 90s, even beyond that. But 90s became, it was kind of 95, 96 and beyond that, right? Mainframe, relational database applications came in, right? Things like you might have heard about Oracle, right? All these databases, right? Oracle, SQL Server, later on SQL Server came, Microsoft brought in, right? DB2, you might have heard about, right? That's DB2 from IBM. Then you might have heard about Informix. One time it was there. So there are several of these relational database called RDBMS systems, right? So the whole goal is how to store the data. The idea is how to store the data, how to manage the data, right? As you are building applications, as you are digitizing the business, you need to store the data somewhere. I am a retail store. I want to have a, manage my inventory, manage my sales, keep my store information, my product information somewhere. I need a database system, right? So earlier they were being managed by mainframe. Then the relational database came, right, which made it much more easier because they brought in concept like table. They have, it's not like mainframe didn't have table. They also have something kind of EDB and all that, but it's much simpler architecture, simpler format and all that stuff, right? So you will have tables where you can have your data, right? All that stuff, right? And they, even in the 90s, they built a lot of these applications. If you remember, any people, those who are from that time, build application like on the Power Builder. I'm just saying, right, giving some background of what happened during that time. Power Builder, Visual Basic, you might have heard about all those things. I'm not sure they are still there or not. I know when we came out of school here in, I went to LSU, Louisiana State University. That time we were learning Power Builder and Visual Basic used to be very hot. That time Oracle along with Power Builder, if you know those two things, you can get a job next day. So it was that hot. In fact, that's how I got into Oracle, because I studied Oracle, and I remember I applied over the weekend. On Monday, I got a job in Oracle. So in IBM, that long back. But anyway, so it was very, very hot. Oracle, Power Builder, Visual Basic, all my other three roommates, they all got job in Power Builder and Visual Basic. So it was very hot, right? So you put your data in Oracle, build a UI application on Power Builder or Visual Basic. Now you have application. You can go in and do the order entry, manage your product, manage your customer, all that stuff, right? So that was what it was 90s. So as we, that time, the size of the database, if I remember, in that time, right, it was pretty small. Even 2 GB of database is a huge. 2 GB of database, it's like a huge database that time, right? Now 2 GB is nothing. Now it's all like in terabytes, and even one table could be 1 terabyte nowadays. Number or multiple terabytes, right? So as you see here, right, the demand for what was going on during that time, right? So companies we are going digital. They're putting all their operational systems like sales, inventory, order entry, supply chain, all that stuff in databases and building applications out of that. In fact, during that time, with a lot of applications like SAP, right? SAP came in, and other, there was one PeopleSoft. There are a lot of these applications came in, like ERP systems, enterprise resource. What does ERP stand for? Enterprise resource planning. Okay, ERP system, right? Order entry, supply chain, right? All that things came in. Right? So, but underlying technology, underlying data storage is primarily maybe one of the database, right? Could be Oracle, could be SQL Server, and all that, right? So this is your package used to be. Now, as the 90s, towards the end of the 2000, I would say, towards the 2000, right? The data volume was slowly going up, right? As companies are adopting these new technologies, right? They're putting their operational systems or digitizing their operational system, and business is growing, right? So now more and more data is coming in, like Walmart in the 90s, and now definitely number of stores has grown. more customers, more products, everything. That means the number of transactions we have then and now is much, much bigger. That means what was happening? So demand for better storage, processing, right? So these are some of the better, bigger storage, bigger processing speed, all that stuff, right? That was what kind of driving, new innovation, I would say, right? So, okay, if you have a database of 2 GB, after 1 year or 2 year, oh, my database is full. What do I do? Oh, you know what? Go ahead and maybe add some more space, or go ahead and buy a new machine, right? So that was the kind of trend. So so the problem statement here, where what I'm talking about is the platforms or the hardware or whatever they're using, they are not scalable. Okay, what do you mean as scalable? When my demand for storage and processing is going up, the platforms cannot scale. They cannot. It's not easy to scale it up. Like your laptop, right? As your laptop gets full, your storage is full, and you keep on adding more data, but then you are processing. Maybe you are running some big processes, right? And then at some point you just hit the limit, right? Upper limit. Then so what do you do after that? Oh, you know what? There is a bigger laptop, i5, and now I go for i7 or i10. Better processor speed, better 1 terabyte. Now you have go for 2 terabyte. So that's how you have upgraded. If you have been in this in here or somewhere in last 20 years, you have upgraded your laptop, right, over the years. So that was the only option that time. Okay, what does that mean? They are not scalable. Scalable in the sense they are not horizontally scalable. So there are two types of scalability. Okay, horizontal and vertical. And vertical scalability is limited. Why? What is vertical scalability? Look at your own laptop, right? Your laptop. Oh, I will tell you, hey, go ahead and install Hadoop and all that. You say, hey, I have only 4 GB memory. What do I say? Okay, go ahead and add maybe 8 GB of more memory. That will help you install Hadoop. So you go in and buy a new, memory chip and add it. So now you have instead of 4 GB, you have 8 GB or 60 GB, whatever, right? But that has a limit. You can't just keep on adding 32, 48, right? There is a limit how big you can add, right? There's a limit for the configuration you have. So you can vertically scale. That's called vertical scaling. Or you can add a little bit more storage, add external storage. That's all you can do to your laptop. Add external storage or add some new memory chip. That's the only extension you can do, nothing else, right? Because your compute is pretty much built. That's, you are not changing your what you call platinum or Pentium and all that. That chip is you are not changing it, right? Then you better go and buy a better new laptop, right? So anyway, so that's why we call it horizontal scalability is limited, and vertical scalability is limited. Horizontally not scalable. Those platforms, they are just like your laptop. They were kind of like your laptop, bigger server, but they were not scalable. So the result is buy a new machine. Whenever you hit the limit, okay, you buy a new machine. That means more investment. Maybe spend another $1 million to buy another server, right? So that was the solution. Okay, the solution is buy a new laptop, or so not laptop, buy a new machine, spend another $1 million, couple of $1 million to right. So that was the kind of a trend until 90s, end of the 90s, I would say end of towards the 2000 or all that. Then so you have mainframe, you have relational databases. Another thing was happening, right? After 2001 to, right, the recession happened after the 90s hype of the what you call internet boom, then bust happened, right? So one thing people realized, right, that analytics, the role of analytics, okay, analytics is key to the business success. Okay, key to business success. What does that mean? So why did my business fail, right? what could I do to sustain my growth? What could I do to grow my business? Those kind of stuff. Those answers will come from analytics, right? That's not doesn't come from your operational system. That's like operational means daily things, what is going on, daily sale and all that. That's operational, everyday thing. But to analyze how your business is doing, you need to build something called data warehouse. That means I store that data for 5 years, 7 years, go back and analyze it, check. Hey, how is my business doing this year versus last year? How is my business doing this year versus 2 years back, right? So data warehouse, BI, business intelligence. So these are the things which became after 2000. These became very, very key technologies which picked up, and they have been there till now. They will always be key technologies because analytics will never go away. Because business, the data volume is growing, platform is getting better at everything, but business data warehouse, BI, business intelligence, analytics, whatever you call it. Okay, so this will always be there. Okay, this is the kind of, I would say, recession free kind of thing. You can think of it as like a recession free, this technologies. I mean, that's the reason in 2002, because Oracle DBA, I jumped to data warehouse. I mean, that's what I did during that time when I lost my job at 2002. So I moved from a plain DBA to an analytics side. So that's how my analytics journey in fact started. Okay, so analytics area, if you are there dealing with data, analyzing it, you will never run out of jobs. Okay, of course, platform and technology is one other thing. If you stick to a old technology platform, yeah, you may get, but if you stick to the current technology and be in analytics, that will always be, you will be your safest job, to tell you the truth. Okay, so now those things require, what does this application need? They store massive volume of data. So you need to store lot of data. How do you do analysis unless you have a lot of data? 2 years data, 5 years data, 7 years data, right? And if you remember that time, because of those financial crisis happened over the years, a lot of government laws came in. Right? Government wanted every companies were financial companies minimum they need to store 7 years of data. They need to have it. These are all compliance and regulatory needs. Otherwise, you'll be fined millions of dollars, the companies, right? So you need to store a lot of data from government regulation, I mean legal requirement, as well as your company will also benefit, right? If you have a lot of data, you can analyze better, right? You can take a better business decision. So you need to store a lot of data, right? So you need a better platform, bigger platform where you can store the data with cheap cost, right? Cheap hardware cost and all. But if you just storing the data is not enough, but I have to process it also. Process it faster. Right? So just storing the data, 10 terabytes of data somewhere, that doesn't help me unless I can process. Process means basically reporting, right? That's where it comes. If I cannot report the data, report or do analytics, what's the point? Just storing it. So storing and processing. Okay. So those are the two requirements from business analytics and all, right? So this was the kind of pain point during that time. As these relational databases, which I talked about, Oracle and SQL Server, the demand for data went up and up. These platforms could not handle anymore. Okay, these platforms, Oracle, SQL Server, DB2, they could not handle anymore because they were not designed to do analytics. Why they were not designed? I took one concept I will bring in here. Do you know what is called OLTP? Online transaction processing. Online processing. Okay, that means these databases, okay, this Oracle and all that, they are good for online transaction processing. Oracle, SQL Server, all those databases, DB2, they're designed to do online transaction processing. What does that mean? As the name says, transaction processing, these are like, oh, I want to update my customer record, change his address, change his phone number, change his marital status, or am I adding a new customer, which is an insert operation. Think about SQL term. Those are like insert, maybe update, maybe delete. Customer is gone, I want to delete. These kind of operations, insert a record, update a record, delete record. Okay, These are called transactional. They are very transactional in nature. We have 10 million customers. I want to go and update record of maybe customer with social security number is XYZ. So basically your query will go update this table where this customer ID equal to this, right? This is how you do in a SQL. Update this table where this equal to this. So this means in the 10 million records, you are updating one record, or you are inserting a new record. Okay, new record, new customer coming in, insert into this table, customer table, this, right? Or you want delete, maybe customer is gone, you want to say delete from this table where customer ID this. So these are called transactional operations. Okay, to make that happen, this databases like Oracle, SQL servers and all, they have inbuilt, the engine is built for that. They are very good at that. Okay, they have their engine is built for that. They have lot of inbuilt. I will not go into technology into the details of it because I used to go Oracle DBA. So all that stuff, they are built for that. Okay, so that those are very good. But when we try to fit in the online transaction processing engine to become a data warehouse, which comes like OLAP, online analytical processing, they did not work that well. Okay, online analytical processing. So when you try to fit in a machine or fit in a platform which is not designed for it, they don't work. They work to some extent. In fact, that's what I was when I was working for Neiman Marcus that time. Our data warehouse was built on Oracle. I'm talking 2002 to 2006. Okay, so it went up to 2006. I remember every Sunday we used to run batch jobs, and our reporting used to be in Power what is called business object. So and as the volume of data went up and up, the reports used to get slower and slower. 2 hours to 4 hours, 8 hours, sometimes Monday morning. By the time we go to work, still not complete. So your SLA service level agreement, everything you are kind of starting to violate those, right? So that means platform is not big enough to process your data overnight and get it ready by the time users come in 8:30, right? It's taking time. Batch process is running time, taking a lot of time to do the what you call ETL and reporting. We'll come up with that. So OLAP will have ETL, extract, transform, load, and reporting. So these are the terminology you will learn, because in big data, in AWS, it's all about ETL and reporting, by the way. It's all about analytics. Okay, we are not solving the OLTP problem here. We are solving the OLAP problem. Okay, so that's why these terminologies will slowly get used to. ETL, extract, transform, and load. Like the processing the data before you do reporting. Okay, so these are the things we will call, and reporting maybe with something, maybe with business object, maybe some other reporting, right? So as you see here, so that means the industry found out, hey, we need a different kind of platform. This Oracle SQL Server are not working. We need something different. Okay, so that's when new technologies came up, called appliances, or called data warehouse appliances. Okay, these are the new technologies came up around 2005, 6, or 2000, around 2003, 4. That those things started coming. What are those platforms? Some of the names: Netezza, which was eventually bought out by IBM. Teradata, you might have heard about. These are databases, but these are specialized databases. Okay, there are many others came in later in time, like Vertica. These are all the Vertica. There is something called Green Plum. Okay, these are some of the databases came up during starting from 2005 all the way to 2012. These technologies came up. Okay, so they say, hey, don't use Oracle, don't use DB2. We have a new thing called Netezza. It's like appliance. You go on, load it, and it is lightning fast. Okay, it's lightning fast. It is not OLTP anymore. It's designed to do OLAP. It's designed to do ETL. It's designed to process billions of record and all that stuff. What is the common between all these technologies? They are called MPP. You will learn a lot of this lot of this new terminology. MPP is massively parallel processing. Okay, MPP. See, Oracle SQL Server maximum at those days I'm talking about. Now they could be very, very different. I remember that time we used to have 8 CPU. I'm talking about Oracle in Neiman Marcus when I was Oracle. I think I was Oracle application guy that time. Our server, I remember, if I remember well, it used to be 8 CPU, maximum 8, I believe, not even 16. So if you have 8 CPU, what does that mean? I think with some threading and all that, you could probably have 16 or 32 level of parallelism, maybe 16. See, what does CPU do in your machine? It will create, you can run multiple processes same time if you have multiple processors, right? That's what it does. One of the bad thing about drawbacks about the CPU is it cannot process 2 things same time. It's sequential unless you have multi-processing capability, which in laptops nowadays we have quad core, this, that, all that stuff, right? So you can have multiple processing going in same time. So if you are sometimes your machine laptop gets hung, that means it's trying to finish one, then pick up the other one, right? That's what happens behind the scene. But if you have multi-processing, you can parallelly process multiple jobs same time, right? And so they said, okay, let's instead of doing 4 CPU, 8 CPU of this Oracle SQL Server, we'll have massively parallel processing. Okay, and that was Natija. I remember when we started, our Natija server had 50 CPU. Okay, in Neiman Marcus. We migrated from Oracle to Natija in 2006. Okay, later on I went on to join another company, and remember by 2012 I was running like 192 CPUs. These are like higher version, bigger version of Natija. So that means running a job, there are 192 processes running in parallel. So imagine that will that not be much faster than running 4 and 8 or 16, right? So it will run much faster. The main game changer is these many CPUs, okay? And every CPU is attached with another memory, so you are getting also memory. Anytime you are adding more nodes to it, you just add more CPU, more memory. So one of the thing it did is it's called in computer term, you can say it is linearly scalable. That means as you add more capacity, the speed goes on up accordingly. It's like a 45-degree angle in a XY graph. It's like a 45-degree angle. Think of that. As you are adding more, that is also going up. Those are not true. Used to be, it was not true with Oracle SQL. Even you add something, now you add 50%, it may get 10% increment. Right? But here it is a linearly scalable because every time you add more nodes, you add more CPU and memory. So it's linearly scalable. So this was a game changer during that time. Okay, it went on to like 2012, 13 up to that time. I remember 2012, 13, I was working for American Express, traveling to Phoenix. So that time I was doing most of the Natija migrations. I migrated a lot of DB2 databases to Natija in IBM. I migrated Teradata to Natija in what do you call Bank of America in Charlotte. We also migrated Oracle to Natija many places. So I was used to be a Natija expert from 2006 to 2012. Okay, that was my, so from Oracle to I jumped to Natija. Then around 2012, so what's next? So 2012 to 2013, right? I would say during that time, 2010 and beyond, right? So these appliances were everywhere. Every company was migrating to Natija, Vatica, Green Plum. I mean, there's just going like projects everywhere. I remember. So that time, something new was coming up. That was called, I was talking about that time. So that was now new thing coming up called Hadoop. Okay. So this was coming up that time. It's just becoming public. Things are starting to, industries are starting to adopt. So what was Hadoop? Okay. So and why what did it change? So Hadoop, which we'll be studying. Okay. So I'm just giving a kind of historical timeline of this, how things have changed over the years. Okay. So there is nothing wrong with Natija. There is nothing wrong with Vatica and Green Plum. Although Teradata was very expensive, people didn't like Teradata. It's very, very expensive, extremely expensive. In fact, we migrated Teradata to Natija in there in Bank of America, $50 million project. I think it was done for 1.5 years. I remember. Anyway, so they are great. They are great. These people are great, but they are still expensive. They are not. They are not widely scalable. They will look like your fridge in your kitchen. Okay, they will look like that. They will put somebody like a fridge in the kitchen and you plug it in and it's ready. You can start working on it. You put your data and start working. It's very easy. A very easy setup. Within a few days, your data warehouse is running. Right now, it's very massively scalable and. But when you do scale it, you can add one more fridge. Just think of like you are freezing fridges are you are lining up in your server room. So, but there are some limitations and they're costly as well. One of these Natija box will be a couple of $1 million, something like that. Okay. But the people are very happy. So we sped up a lot of this processing time. One application was running how many 6 hours in I'm sorry, where it is American Express. I think we brought it down to 15 minutes. I remember that's the migration we did. So the timing was very lightning fast. Anyway. So now came the Hadoop, okay, around that time. So what is Hadoop then? So Hadoop is again same thing. It is an open source, okay. It's an open source, massively parallel processing platform. Whatever MPP you see here, it was not open source. It was all proprietary, right? Natija was bought by IBM. Teradata is NCR. Vertica was bought by, I believe it was bought by HP, I think Greenplum, I don't know, bought by somebody. Okay, so these are all eventually bought by big companies. Okay, so they are all proprietary softwares, proprietary platforms. But this Hadoop was open source, completely free. Okay, you can download and start working on it. You can put it on your server. Maybe I'll take 10. So as you see here, another thing, characteristics of this platform is, I said it's massively parallel processing, linear is scalable, but they are also multi-node. Okay, they are multi-node. When I say 50 and 190 CPU, they will have 50 computers in that box. All there are 192 computers, separate computers together. They put it all together in a network. Okay, so there are multi-node, many nodes or many node or computers together. That's how they build that massively parallel processing engine. It's not a single machine. It's a many machines put together. Okay, so now same thing here happens, right? This is also multi-node. Okay. Only plus point is here the software is free. Okay, software is free. All you need to bring in is 10 servers, put it in a network, install Hadoop, and you are free to go. You can start running. You don't have to pay for software. You don't have to do anything, right? All you are paying for is your hardware. Okay, so that was a big game changer. That it is all open source. Okay, and the servers they are using, like here Teradata, Vertica, Greenplum, the servers were very costly. The servers, the appliances which bring in, they are very costly. Here the it was I can have what you call hardware. You can have commodity hardware. What is commodity hardware? Just like your laptop grade. Not that cheap. Your laptop can crash, right, anytime. It's not to that level, but it's called commodity grade, commodity hardware. Not a very high grade hardware. You don't need it. Okay, why? You will understand that in a minute later on when we talk about HDFS, because it's built for resilience. If one of the machine goes away, it has built-in resilience or it has built-in redundancy, so your data will not be lost. Okay, so why to pay 100K? So like for example, the cost of 1 terabyte storage is, if you go for high grade, right, servers, it could come up to 100K, $100,000 if you go for high grade. But if you go to commodity hardware, okay, 1 TB commodity, it could be just $500. Okay, it could be just $500 or maybe less than how much you pay for your laptop. I mean, 1 terabyte you just bring, right? It will be very, very cheap. But you go for high grade, it could be up to 100K. Okay. Maybe these numbers are a little old. Maybe 100K might have come down a lot. But what I want to mean is there's a huge difference. $500 versus 100K. It's much, much cheaper. So I can easily afford $10,000, build my Hadoop platform, take the software for free and put it there. I have my Hadoop environment. Whatever I was paying for millions of dollars here, I can have the same thing ready with a much, much cheaper cost, right? And they are also, if I put 10 nodes or 20 nodes, and each node has 8 CPU. So 20 multiplied by 8, 160 CPUs. Now it is kind of equivalent to this, right? 192, 106, right? So you are getting similar kind of performance. Again, I'm just giving some equivalence of it, but that's what can happen. And that was a game changer. Okay. So then people say, oh, great. So now instead of paying for all these things, I can have an open source MPP platform called Hadoop, whatever the name is, and put my software and put my data there and do my analytics, like do my ETL. See, this is most of the work done in data warehouse is ETL. To bring the raw data, process it, and create reporting layer. That is the biggest challenge in any BI application, right? To bring in raw data, clean it, process it, then make it ready for reporting. That's what you do in reporting or any BI stuff, right? Data warehouse, anywhere, right? So that was now done. That is possibility of doing it cheaply, but still doing it comfortably or reliably. You see, just because it is cheap, you don't go for that. It has to be reliable. If you say, hey, it is cheap, but you can lose data, then nobody will go for that, right? So it is cheap, as well as it is very what you call fault tolerant, robust, all that thing we'll talk about. We'll see that when we get to the detail. Okay, so this is what picked up big time during 2013, 14. It was picking up. Okay, so Hadoop started during that time, and by 2017, 18, everywhere there is Hadoop. Okay, almost all big companies, Fortune 1000 companies, everybody have Hadoop installations. Okay, they migrated because the region of acceptance or high adaptability or adaptability is because you can build huge Hadoop platforms. That means, like for example, I told you, right, American Express, we call it Amex. Amex, when I was there, they had 1,000 node cluster. Okay, they call it cluster, means one platform. Okay. They have 1,000 node cluster. Apple, which one of my company people are working, they have like 5,000 node cluster. Okay, so it's a huge petabytes of data, multi petabytes of data, because there is no stopping how big your platform can become. You just keep, it's extremely scalable. Unlike your Oracle and SQL, you can add more. You want more data to store? Oh, go ahead and add 50 more nodes, no problem. So it is very scalable. You just keep on adding computer, keep on adding computer, keep on adding servers, or what you call node. Node is nothing but those servers. Okay. So currently, if you go to Facebook, Yahoo, big companies, right? They have servers. They have server farms which are like 50,000 node cluster, 40,000 node cluster, huge server farms, right? That's where they store their data. Okay, so that's where they store the data. That's extremely scalable. Okay, so this is the Hadoop. Hadoop time was between 2010, 12 to 2018, 19. It's extremely popular. They're still popular, but then, as I said, around 2016, 15 maybe. Then the whole AWS, Amazon changed everything, right? The cloud thing can change everything. They said, hey, you don't need to manage your servers anymore. You don't need to install it. You don't need to do all that stuff. Just come to us. Okay, just come to us. We'll manage your server. We'll install your patch. We'll give you everything. What do you need? You need database? Okay, we have database on cloud. You need Hadoop? We have Hadoop on cloud. You need application servers for your web applications. Okay, we have something called VMs, virtual machines. Anything you need, it's there. AWS, you go have more than 150 services. Anything you need, relational database, NoSQL database, Hadoop. I mean, there are so many. I'm not going into that, right? Everything is there. And you don't need to pay for any of those hardware. You are paying for the services you are getting. Okay, you are paying, you are renting out. Okay, now who will patch up the, suppose the software is, went from 3.0 to 4.0. You don't need to worry. They will apply the patch. They will do everything. Right? That's the biggest. So they say, hey, what they call is called what you call managed service, right? That became very popular. We manage everything. You just pay for the rent. You just rent it out. We manage everything. Of course, there are different models. Platform as a service, infrastructure as a service. What is the other one? Software as a service, right? So there are different things. You'll learn it when you in the cloud class starts. They will talk over all that stuff, but I'm not. But there are different different models are there. But look at the benefit of it. The same Hadoop cluster. If you want to build a Hadoop 10 node Hadoop cluster on-prem today, it is a matter of 3 to 6 months of effort, starting from budgeting, the whole thing of buying it, setting up the network, putting it in somewhere, right? It's a lot of hard work. Then your platform will be ready. Now you go to AWS, right? You go to AWS and you said, hey, I need Hadoop of 10 node Hadoop cluster. There is something called EMR, Elastic Map Reduce. 10 node server, 20 node server cluster will be ready in 3 minutes. Okay, in 3 minutes it will be up and running. You just go and click and say, okay, start. In 3 minutes, 10, 20 servers is ready for you. Okay, you don't want to use it, terminate it. Next day, done. You pay for the whatever you use it, right? Whatever you paid for one day, you just pay for one day. Okay, so this is the beauty of cloud. No doubt, no wonder cloud is so growing like crazy, right? So anyway, so that's the reason, right? So we are in the cloud world, and all these platforms which were built on Hadoop during the last 10 years, now all of them are migrating to cloud. Okay, so many projects, many migration projects are currently in progress or going on, where you will be if you happen to join any company after this class or whatever, you might be doing some migration work, migrating from on-prem Oracle to cloud, Hadoop to cloud, something like these are a lot of things are going on. So you might end up as a migration data engineer, cloud data engineer. Okay. Any questions so far? So this is the kind of historical what do you call timeline, how the business needs have grown over the years, last 20, 30, 40, 30 years, and how technology has changed and why it has changed, what is the main driver, right? And we are here now, cloud, we don't know 5 years from now, 10 years from now where we'll be, right? But but it's, as you see here, key things is what we are looking at. What we see here is we as I said here, okay, the main problems we are trying to solve, as you see in this picture, is 3 things. Okay, we know this is what is happening. The volume of data is increasing day by day. Okay, it's growing exponentially. In fact, the world's data volume is doubling every 2 years. Okay, there's a graph somewhere here. So here is the graph. It is an old graph. 2020 we are on 2021, but you see the volume of the world's data volume is doubling almost. If you look at this, almost double. Here it is 20. After 2 years, it's almost 40, 45. So it's doubling, right? And the reasons are very very clear. We have mobile data, we have social media data, we have pictures, we have movies, we are sending pictures to each other, texting, we are putting on the Facebook, we are Instagram. Think about it, right? Everywhere there is data. You are doing shopping, your clickstream data, like that you are going to your site looking at, that also creates data. Everything you do nowadays creates data, and that is stored somewhere. Somebody is storing it, somebody is analyzing it, whether it's Facebook, whether it's Yahoo, whether it's Google, whatever you are doing, somebody is analyzing it. So right, so data is like the new oil of 21st century, they call it, right? Data, more data you have, you are like more rich. Okay, so that's your so volume is increasing, we know that, right? That's exponentially increasing. And other thing is the velocity. If your data was coming every day, every month, every week earlier, now it is coming every second, right? So the data has become real time, data has become coming streaming, all that stuff. Whether you are doing video streaming nowadays, it's just a matter of time. Hey, you do video streaming between continents without any problem, right? As you will see 5G come in, I mean, doing what you call heart surgery remotely will become a feasible, right? Become feasible because your 5G speed will be so high. I mean, you can do pretty much anything remotely, right? So think about the possibility of the thing, right? So your data is your platform, your system is becoming, or your data is coming in real time, in stream, in near real time. So its speed is going up. Variety. You are no more just sending data in a structured format like customer table, sales table, inventory table. These are structured data format. Now data could be semi-structured, unstructured, pictures, movies, any clip, text, everything is valuable, right? So those data needs to be stored. This data needs to be analyzed. There are companies, all they do is analyze your text. What are you saying? What are you texting? What are you writing in the Facebook? Everything is getting analyzed, right? There's a lot of value in that. So they can do marketing. They can sell the right product for you. Okay. So these are the three changes that we call it 3V. Okay, published by Gartner's. 3 V's of big data. Volume is going up and up. Velocity is going up and up. Variety of data is also going. It's becoming more varied. So what do we do? Now you need a better system, better platform, all that stuff. That's the reason big data came in. Okay, that's the reason we need a big system which can handle this data, because the volume is going exponentially high. Okay, to handle it, that's the reason we have called Hadoop. Okay, so let's see, as Hadoop came. How did it come, by the way? How did Hadoop come and where did it come from? Okay, so where did it come from? So let's talk very briefly on that. Who joined? I'm sorry. Waiting for name. Who just joined? I don't see your name. Okay, I'm not sure who joined. Okay, maybe you want to stay mute. Name doesn't show up. Maybe you can mute yourself so that the background noise is not there. So please mute yourself, or I'll mute you anyway.
I have one question, Radhikant.
Yeah.
So Hadoop, does it require any integration tool like MuleSoft and all we use, right? For certain times, like, so does it require any integration tool or something?
MuleSoft and all that stuff, you are talking about the middleware and all that. I know.
Yeah.
Don't know
Does it
much
require
about
or
MuleSoft.
is it like? Hello.
No, go ahead.
Yeah. So is it like Informatica? Otherwise, like Informatica, you don't need an extra thing, right? It can do both ETL and this one, right? So that's like, I just want to know how Hadoop works.
So yeah, so it's not MuleSoft, or it is not just Informatica. Like Informatica is just a tool, which is a ETL tool, extract, transform, and load, right? Even it doesn't have its own data. It relies on some database like Oracle, SQL Server, and all that, right? It needs storage. right?
Yeah.
Even if to put Informatica, you may want to install in somewhere which you need some application servers and all, right? But
Yeah.
here Hadoop you are talking about, it's a platform.
Mhm.
It's not just a software. It's rather more a platform where you have storage and you have compute. Okay.
Oh, okay.
So we'll
It's
go.
all
That's
in
so we
one
will have.
package, all in one, everything you have.
Yeah, all in one. But
Oh.
it doesn't solve all your problems, by the way. Okay. It will not solve your problems of middleware, your real some of the things it cannot solve. But what it is good at, you'll see that. Okay, there are but some of the main majority of the stuff that problems we face, those are the things it solves. Okay. So storage and compute, those are the major issues during the early 2000 and beyond, right? This is where the major industry problem. How do I store the data? How do I process it, right? Primarily for analytics, even just to store it. As the data volume was growing up, I need to put it somewhere at one place. We call it enterprise data warehouse, like they call it enterprise storage. If I'm Walmart, I want to store all my transaction at one place. Without that technology available, then maybe it's very difficult to store in a Oracle database because it's so huge. 7 years, 10 years of data, right? Where do I store it? File, yeah, you can put in some file, but file where? In a server or many servers? So we didn't have a common place where I can have petabytes of storage and still you can make sense of it, right? They're all related. That you need. And to be able to process it, compute, right? So those are the two major challenges. Then everything else falls into place, right? But anyway, so we will come to the rest. But these are the two major challenges it solved. Okay, storage problem and compute problem. That means it can infinitely scale in storage, infinitely can scale with compute, which was not the case earlier. I would say not. I would say infinite, but as in quote unquote. But it's pretty scalable. Okay. So where did Hadoop come from? Very brief background on that. Okay. Hadoop is a MPP or massively parallel processing platform. I told you, right? It is MPP platform is nothing new. Processing your application in multiple processor is nothing new. It has been there even before 1970s as well. But it was done in different way, right? But here it's just done in a massive scale. That's the only thing, and became more commodity or more what you call common. It became more common. Okay, that's the only difference. So Hadoop, right? As I said, right? So it came from two major white papers published by Google. Okay, just white papers published by Google. One in 2003, around October time. Another one is 2004 April time. Okay, I don't have the exact time, but something around that. There are two white papers. Okay, the white papers published by Google, and those white papers are, one of them is called GFS, Google File System. Other one is called MapReduce. Okay, these are two white papers. GFS stands for Google File System. Okay, and MapReduce is MapReduce. We'll talk about that one. So these are two white papers. Basically, what Google is saying in these two white papers, you can search it and Google and find it out, by the way. And Google GFS says, hey, we have a innovative file system where we can store petabytes of data. That's what it says. That hey, we are not limited by the size of the file system anymore. We have a innovative system or innovative platform we can scale infinitely, because Google was handling petabytes of data by then. So they had, and they keep very secret, right? Their technology is very secret. They are very secretive, and they are very proprietary, and they are always way ahead, 10 years ahead of others anyway, right? So then also the second white paper, which was produced, MapReduce, they say, hey, we not only store this data in a massively scalable storage platform, we also know how to process it. That means we know how to do distributed processing. Okay, here is the key word: distributed processing. When you store your data in many nodes, many servers, it's not easy to process because it's not at one place. How to process that? That means your processing has to be distributed as well. Okay, so nowadays, in fact, it has completely, nowadays everything is distributed. You go to cloud, you name it, everything is distributed, right? There is no single processing engine anywhere anymore. But this is how it started. So your storage is distributed, your processing is distributed. This is distributed storage. What does that mean? If I'm storing a 1 terabyte file, and I have I'm storing it in a Google file system, it's not sitting, that file is not sitting on one server. The file is could be sitting in 10 servers. That means it is breaking they break the file and distribute it among the 10 servers, but still it is one file. Okay, still from the user standpoint, it's still single file. And when it comes to processing, it can also process those 10 slices of data in parallel, and make, you don't need to know, it will bring the data out and give you the output data, whatever you need. Okay, so distributed storage and distributed processing, because it was feasible, now you have no limit. If I can distribute storage, what is the bottleneck now? Nothing is going to stop me to grow from 1 terabyte to 1 petabyte, right? All I have to do is what? Keep on adding more nodes, keep on adding more servers, keep on adding more servers. So there is no physical limit, to tell you. Okay, to impact. So it's a very highly horizontally scalable platform. Okay, so when these two white papers came in, then we had the open source community, Apache, you all know, right? Apache community. So they went in and start building something called, based on these white papers, they started building something. Apache is an open source community, right? People like you and me contribute to the projects, and all over the world, this is how they build the software. Okay, so they built something called HDFS. HDFS actually came in from GFS. From Google file system, what was built called Hadoop distributed file system. Okay, so this came from GFS. Okay, so this is called Hadoop distributed file system. Okay, similar technology, similar principle. They build it using, they say you can put the data in 10 servers, 20 servers, 30 servers, 10,000 servers, and it will look like a single file system. And the software that goes behind it, that's what they built based on this GFS. And then after that, they added MapReduce, same name. They said, okay, now also based on the white paper, they built this is a distributed company. Okay, so this was all done open source. Software was free. It was built in Java, by the way. Okay, the software written, the Hadoop was written in Java. Okay, so they build the Java, so you can go in. So these are the two things they built. And if you remember in the when I was doing the introduction, I think first day, I think the demo session, I don't know, no, I think that was last class. Okay, I didn't talk about this. Funny. So if I go to the maybe picture, that will so much more easy. Where is it? Okay, here. So this is a typical Hadoop ecosystem. Okay, when it's a Hadoop ecosystem, it's a platform. I told you it's a platform, right? It has many things. So at the bottom, you see HDFS. You start with storage. First, you need to have some place to store the data. That's called HDFS. Again, this is not one server. It could be many servers. It's a distributed storage, as the name says, Hadoop distributed storage. Then I'll have MapReduce. Don't worry about the YARN, MapReduce, version 2 and all that. Think of MapReduce. Then I have a distributed processing framework. So two frameworks: storage framework, processing framework. Now I take care of two things, major things. I have no worry. I don't have to worry about storage. I don't have to worry about processing. Then what? So if those two things are taken care of, right, now I can build applications on top of it. Just like you are saying, I want to do ETL. Like if I want to build a reporting application, I need to do some data processing, which is called ETL, extract, transform, load. So this is, or if I have the data here, file system, I need a database, because not everybody knows how to go to the file and look at the data or write C++ program, right? Somebody who, I would rather have some system where user can go and do a select star from some table. That's much easier, right? People are more database savvy than writing C, Java program on that, right? So you need a database. So that's why the new applications started coming in, starting with Hive, Peak scripting, and those are the two major. Okay, Hive and Peak, they came in. Okay. So what is Hive and Peak? So first, so now this thing come in. Now next thing is on top of storage and compute, we need a database. Okay, so they brought in something called Hive. Okay, Hive came from Facebook. Okay, so Facebook built Hive. They built it for their own reason. Okay, their own requirement was there because they are storing massive amount of data. They wanted some analytical system. Just putting it in Hadoop didn't help. Think about it. Just put anything, something or HDFS. How will I analyze it? Am I going to write C program for this, C++? Yes, you can do it, but it's not user friendly, right? So if you have my business analyst is sitting there, how will he look at the data? So they started building a new tool called Hive. This is a database. This is the database on Hadoop. Okay, so they built a database on Hadoop, and eventually they open sourced it. That means they gave away the code. Okay, it was open source, I don't know, 2008 or something. So that means they gave away. Okay, here is you take it in, you take it, you gave it to Apache community. They said you go and maintain from now on. Now it is open source. So they added to the thing. So the ecosystem, now we have a new thing called Hive. I don't know when came, which one came first, which one came later. I think Hive came first. Then Peak came. Okay, they said, okay, we have to write ETL. You said, right? We have to do write ETL, extract, transform, load. We have to do the data processing. How will you do it? We don't have Informatica here. We don't have all those tools here. How will you do it? So, and everything was written earlier, everything was being done by Java. In fact, in the beginning, 2012, 2013, people used to write MapReduce programs in Java. Everything was written in Java that time. So it's difficult to deal with data with a Java programming. It's not a nice language to deal with data heavily. It's okay to build applications. That's different thing. To build a database application in Java, that's not a great tool to do that. Okay, we need something else, ETL tool kind of thing. So that's when came Pig, PIG, Pig and Pig Latin. Again came from Yahoo. Okay, and eventually it became open source as well. Okay, that means they also gave away to Apache community, so that now it became part of the Hadoop ecosystem. Okay, so now we have a database. Now we ETL. Already you have storage and processing. Okay, great. See, that means Hive, whenever it's running, it is making use of the HDFS as storage, and it is making use of the MapReduce for processing. When Pig is running, it is making use of the MapReduce for processing. All it is doing is a wrapper on top of it. Okay, because anything has to be computed, has to be processed in this platform, has to be done in MapReduce. Otherwise, it is not distributed, right? Think about it. If you have my data on 10 servers and there is a MapReduce for distributed processing, I will say, oh, I don't want to use MapReduce. I will do my own Python thing. It's not going to work because data is in 10 different servers. How will your Python talk to second server, third server, fourth server? Are you going to write software for that? You can, but why to do that? Let MapReduce handle it behind the scene. Okay, so that's what they Pig and Hive internally use MapReduce to do the compute. All it provided is a wrapper or a interface to the user, so that he thinks, oh, I am working with a database, but behind the scene it's all file system. Here I'm thinking, hey, I'm working with the ETL tool, but behind the scene it's all MapReduce. Okay, so that's how they built this platform. So Hive came, Peak came, and kept on adding. This is not the whole ecosystem, by the way. There are many other components came in. There's something called Scoop. So Scoop is I want to bring in data from outside platforms to Hadoop. Scooping, just like from relational database, I want to bring in data, put it in Hadoop. How do I do that? So you need a tool, kind of utility tool. So this is like that kind of utility tool. Okay, it's like what you call a bulk loader, you can say. bulk loader. We need a loader so that we can bring in from outside to put it in Hadoop. Okay, so it's a bulk loader. So it's kind of some utility tool in the project. Other tools came in like Flume, F-L-U-M-E. Okay, Flume is one say, hey, now so far we have been talking about batch jobs. Batch, you know, right? B-A-T-C-S. Batch is which runs once in a day, once in a month, once in a week, right? Runs for 1 hour, 2 hour, 3 hour, gets a job done. That's called batch processing, BATS. But also we need real-time streaming. Okay, so this is kind of streaming to handle streaming jobs. Okay, so they added a new tool called Flume. Okay, if your data is coming in real time, think about your web server is running. People are going in there. What will it create? It will create Apache logs or whatever the server you are running, Apache server or whatever you are running. Logs will be created, web logs. I want to stream it in real time. You can use Flume and all that. Okay. So as you see here, you are bringing in, making the ecosystem complete slowly. Okay, I need storage, I need compute, I need a database, I need ETL, I need a bulk loader, I need a streaming, and there are some other things like Zookeeper, as his name says. You don't use it, it's just behind the scene, it does the coordination. Something called Mahout, then the machine learning came, like machine learning, artificial intelligence, those things, they added something called Mahout. Okay, Mahout, so that they can do machine learning, regression, classification, all that stuff, right? So those kind of stuff. Then they said, okay, we need to add one more thing called HBase. Not HBase, we'll add something called NoSQL. So there are many types of database. One of the databases is called NoSQL. You learn that very quickly. I will cover that at some point. It's not like your traditional database, Oracle SQL Server. It's a different kind of database. Think about Facebook stores all your data in a NoSQL database. In fact, they store everything in HBase, by the way. Facebook stores the backend data in HBase. Every month they store more than 1 petabyte. 1 petabyte of data means 1000 terabyte of data worldwide is produced every month. That's like a few years back, the statistics. I don't know. Now they have 2 billion users or more than that. They may be storing 2 petabytes of data every month. To scale to that volume of data and to maintain the speed the way it is does, you cannot handle with any other database. So HBase NoSQL databases are very good with that. Lightning speed read, lightning speed write. Okay, they are 1,000 times more faster than the regular databases. So you have special purpose databases. Okay, so HBase. This is NoSQL databases. You might have heard about MongoDB, Cassandra. These are all NoSQL databases. There are more than 150 NoSQL databases. There are a few ones which are popular. HBase, Cassandra, MongoDB, Redis. There are some of the things. Okay. If you go to cloud, every cloud has some flavor of NoSQL database. You go to AWS, it has something called DynamoDB. You go to Azure, it has something called Cosmos DB. So they have the flavor of everything. You have, they are the provider. You need to have something. Hey, I need this, I need this, I need. Okay, you go from there. You go for this, you go here. For this, you go here. Right? It's like a store. You go there and you need to have everything, right? So that's what they have. Okay. So HBase. So HDFS, MapReduce, Hive, Peak, Scoop, Flume, HBase, and all that stuff, right? One thing is not added here or you don't see here is called Spark. Okay. So Spark came around 2014, 2012 actually, 2012, 14, around 2014 it became very popular. Why Spark? Why Spark is so popular? MapReduce was great, but MapReduce is not good with. It's very good with batch processing, but it is not very. We'll talk about that as we go along next class and all that. It is not good with ad hoc processing. Suppose I have a data table in my Hive table. I want to query it, and report writer or user want to see the data. They will make a query. Okay, select store some cells from store table. Group by store ID. I want to see the total sales by store. Something like that. So if you run it on Hive, it can run, but it takes a lot of time. Sometimes it takes 2 minutes, 3 minutes to come back. So the online or the user experience is not that good in Hive because, or even Peak, because the underlying architecture or the MapReduce, underlying what you call framework, MapReduce is a slow framework. It's very robust, very good, and very reliable, but it's not fast enough. Okay, so this was how it was during from 2012 to 2018, 17, right? So a lot of these companies, they kind of hated Hadoop because of the MapReduce. Say, hey man, I can store it, but man, queries are so slow. This, that, all that's complaint. Okay, so there are a lot of things they try to do, but a lot of patchwork happened. I will not go into that. At some point, we will talk about that. But eventually came something called Spark. Okay, so we'll talk about Spark this is where we'll go very deep. At some point, 2 classes, need minimum 8 hours of class. Okay, on this. So this is where this came from University of Berkeley, UC Berkeley, and this is what is the difference? They are in memory processing. Okay, in memory processing. And there are many other things, but I will talk about the Spark in detail when you get to Spark class. So Spark replaced your MapReduce. Okay, Spark replaced MapReduce. What does that mean? That means I don't need Pig anymore. Pig was using actually MapReduce. So Pig was popular till 2015-16. Now nobody uses Pig. Pig is not even there. It's gone forever because we have a new thing called Spark. So MapReduce was replaced by Spark, which is like a 10 to 100 times faster in memory processing, all that. So there are many good things. We'll talk about that. Okay. So that doesn't mean that Hive went away. No. Hive is a database. Yes, internally it is using MapReduce, but database can't go away. Database will always be in need, no matter where you go. So database is still there. MapReduce is still there, but it is running behind the scene. Even my company, we do a lot of Hive processing, and behind the scene MapReduce runs on special cases where we need it. But writing ETL, all the stuff, we do everything in Spark. We read the data from Hive, process it in Spark, put it back in again in Hive. This is what we do on-prem, by the way. I'm talking about on-prem stuff. Cloud is different. Okay. So Spark became the popular engine which replaced everywhere. All everywhere, they replaced the MapReduce, Peak scripts, everything got replaced. That was the kind of time 2017, 18, 17, 18 time. Everywhere, Spark was like kind of magic. Everywhere they started changing. Okay, so Spark has a lot of good things. It can do streaming. It can do batch. It can do streaming, which is called Spark streaming, by the way. It can do machine learning, which is called Spark ML. So it can do all the stuff in one platform. Okay, you can write in Python, you can write in Java, you can write in Scala, any language. Okay, any language. So it supports 3 languages. You can do everything. It is in memory. So that because of all these benefits, it became the processing framework for the industry. Last 6-7 years, 5-6 years, I would say. A lot of things have changed since cloud came up. So Spark, I would say it is losing the shine it had earlier, but still popular. Why? In AWS world, I told you probably in the beginning first class that we have the EMR, Elastic MapReduce, glue jobs in MapReduce, in AWS. They are all based on Spark. Okay, now if you want to be a AWS data engineer, you cannot become a data engineer without knowing Spark. Spark is a must. Okay. So that's the reason we'll be learning Spark. Or if you go to Azure Databricks, Spark is a must. Okay. Because Databricks is nothing but commercial version of Spark. Okay. So that's why we are learning Spark. Okay. Hive is not important for cloud world. You may not even never use Hive in cloud. We're just learning in case you are working, you will end up working on-prem in cloud, in Hadoop platforms and all that. That's the only reason. And just to know a little bit of database on-prem, okay? Or you may be migrating, just like in my company CVS, now we are migrating everything from Hadoop to cloud. So person who knows Hive he will understand what is Hive, and then so that he can help, right? So okay. Who all are there? I'm just checking my list. So you guys are okay so far?
So in MapReduce, how do we write programs? Like in, is it like specific, like we write in Java or something, or what kind of language do we use there in MapReduce?
Typically, MapReduce is written in Java.
Java, okay.
As I said, it is a framework. What do you mean by framework? You have to write in a certain way. That means you have to import certain libraries to make it MapReduce.
Okay.
So MapReduce libraries have been built by Apache. You go and import those libraries, and you say, okay, now read this file, do this. You know, again, I'm not. I'll show a sample program of MapReduce maybe tomorrow, so that you will understand. So, but it's basically you have to follow certain template, you follow certain principles, and you make sure you import those libraries which are written by Apache. Then only it becomes MapReduce. Otherwise, it won't. Just
and
writing
it is specific to MapReduce, right? Whatever the libraries, because for Python, when we import like pandas or data frame or anything, it's open source. Right?
Yes, it will not become MapReduce. So it's typically it is all written in Java. So since the underlying libraries in Java, you have to go with Java programming.
Okay. And it's specific to MapReduce, right? Whatever the libraries that you're saying.
Exactly, specific to MapReduce only. But similarly, Hadoop has other libraries as well. For example, you want to do machine learning, it has some Java libraries and all that. But think of MapReduce as your underlying processing framework. Whether you are doing database processing, ETL processing, whatever processing, the processing framework has to be MapReduce. Otherwise, you are not running your job on a distributed platform. You are running on a single node. And that is not the purpose we are doing, right? That's not the purpose anyway. The whole purpose is to make it distributed. Okay. Same thing, Spark, everything you see here, they are all distributed. HDFS is distributed processing. Flume is distributed processing. Scoop is distributed. Scoop uses MapReduce behind the scene.
Okay.
Spark
is it like MapReduce? Is it like more like the notebook in Databricks? Is it like comparable or?
Notebook? No.
No. Okay.
You're talking about notebook as in notebook, Jupyter notebook?
Yeah, Jupyter Notebook. Is it like something, I'm just trying to understand, like, so is it like Jupyter Notebook is compared to MapReduce? Because we just use it and we use any kind of libraries we import and write notebook, right?
No, so, it is more, it's more about the how you process the data. So think of your data is on 10 different servers. Okay, the data is on 10. We'll talk about that in fact in depth tomorrow. So, so if you are, since you asked it just very quickly, your data is not on one server anymore. You are writing a Python program, yes, unless you do multi-threading. So your 10 servers are there. Think about it, right? So your data is on 10 different servers connected in a network. Now I will put a file. The file is not a single file anymore. Your one piece is in server 2, another piece of it is server 3, another piece server 4. Who is managing it? HDFS. You don't need to worry. It breaks your file into 10 different parts or 20 different parts, puts in different server. Now I will say, hey, can you count the number of words in this file? How will your regular Python work? It will not work because Python doesn't know how to read data from 2 different servers. It doesn't know. It will read only from your current file system, wherever you say, hey, read this file, which may be CSV or that, right? You don't know how to tell him, hey, read this file, which is in 10 different servers. It doesn't know.
Okay.
To do that, only MapReduce knows how to do that, right? So only MapReduce do that, which will look like something like this. That means your data is in 3 different nodes. It will process in a certain pattern. That's what you say. It has called, that name comes from mapping and reducing. MapReduce. There is a certain process it follows.
Okay.
Splitting the data, mapping it, shuffling it, reducing it, then finally writing it. It goes through a life cycle behind the scene. It's completely different from how you have been thinking processing is. Okay.
Okay.
That's why it is a framework, not just something, hey, I will write it, take a Python and do that. It's a framework.
Okay.
Because the problem is complex. Problem is that your data is not at one place and you want to process in parallel so that you can gain the speed. Only way I can gain the speed is if I will be able to process it in parallel. See, if you do sequentially, you are not gaining time. You can run it in parallel 10, 20, 30, 40, 100 threads together. That's where you gain the time. But that's not easy when data is distributed. One piece is here, one piece is here, one piece here. How do I count it together and give the data like this? That's a challenge, right? So that's what MapReduce does. Okay.
Okay.
So anyway, it's a complete frame. Okay. So okay, whether it's Hive or Pig or you are writing MapReduce in Java, behind the scene, it's all distributed processing. It does this thing. Okay, and it works very well, very robust. Anything fails, it knows how to recover. Everything is very automatic. So, but as I said, it's not that user friendly. Where it is not that user experience is not that good. That is interactive experience is limited. It's very slow, and there are many other bad things we'll talk about, and many other weaknesses. That's the reason Spark came. Spark, okay, you don't need to worry about all that. Now it can run much faster. On top of that, you can do streaming here. You can do ML here. Everything you can do. You don't need to switch tools for that. In one tool, you can do everything. Okay, that becomes Spark. Okay. So in fact, many companies, machine learning libraries, machine learning, everything programs have 90% of the places have been written in Spark ML nowadays. Spark ML is a popular machine learning platform everywhere you go. Although it is changing now a little bit, quite a bit because of the cloud, but it has been, the work I have worked since 2016, 17 in Spark. Everywhere, right? Big companies, they have all migrated to Spark. Spark streaming, Spark machine learning, Spark ETL, everything is in Spark. Okay. So same data, which is on HDFS, same data, which is in Hive table. Now the processing is in Spark. Okay. That provided a very efficient processing framework. Okay. So that is all your what you call right. So this is what your Hadoop ecosystem all together. When you install Hadoop, all these things come together along with Spark. So that means when you put it in place in your 10 node cluster or 100 node cluster, you get everything. You have storage, you have processing, you have this database, you have ETL, you have Spark, you want to bulk load, you have Scoop, you need NoSQL, you have HBase, and rest of the stuff. And on the top, you say Ambari. Ambari is so this specific diagram you are seeing is from a company called Hortonworks. You might have heard about it. So Hadoop was all free, open source, but you don't use a free software in your enterprise, right? You need to rather go to a company, rather pay some money. I would rather have a somebody who will be responsible if something goes wrong. So that's where the commercialized companies came up. Which are the cloud Hadoop companies came up in the last 10 years? Cloudera. You might have heard about that. Then came the Hortonworks. These are companies which are startup companies, used to be went public in the last 10 years and became, these are all Bay Area startup companies. Which, what did they do? They took the Hadoop, the open source product, and they packaged it and sold it. That means they licensed, packaged it. Okay. What additional stuff they did? They provided something called provisioning, managing, and monitoring software. On you have the everything else. So how will you manage the cluster? They provided a UI for that. User interface, nice interface. You can go in there, you can provision this, right? So which is called a Hadoop manager. Think about a Hadoop cluster management software. They gave it on. That's they build it, put on top of this. He said, hey, take this platform. Now you are using Hadoop, Hortonworks version of Cloudera. Sorry, of Hadoop. Or Cloudera came in, hey, take this thing. They built something called Cloudera Manager on top of that, and added some new components here and there. All that stuff, they made it look nice, all that stuff, and license it. Okay. And if something goes wrong, you can go to the Cloudera engineer, go to the company. Hey, my system is running, now it failed, this, that. Their engineers will come back, come to your company, charge $300 per hour, and fix the stuff. But at least they will fix it. But when we go to the open source community, hey, my system is not running, fix, nobody will come, right? I would rather pay somebody, but get the things fixed. So that's what these companies, they actually Hadoop companies, okay, who sold this open source product and basically license those products with a fee, okay, and that's how they made money. But unfortunately, these companies have gone bust in the last 5 years. Why? Cloud. After cloud came, everybody wants to cloud. Who wants to build my 10 node, 20 node, 1000 node cluster? If any new company now they are starting to build a Hadoop platform, nobody will go for, hey, I'll put a 100 node cluster here, have a Hadoop admin, set up network. It's a lot of work. It may be cheaper and all, it's a lot of work. Patching it, this, that. Why to worry about that? Just go to cloud. Let AWS manage it. All I go there, okay, go to EMR. I need 100 servers. Within 5 minutes, it's ready. That's okay. We'll pay for it. I don't need it. Just terminate the servers. Done. See, it's made it so easy. Cloud made this, so easy. So these companies lost their values. Their stocks plummeted, and they are, I think, the Cloudera stock last time, I don't know how much. It went completely bust. They are still there. My company, Cloudera, then bought Hortonworks 2-3 years back. They are now one company. There used to be another company called Mapper. The company got sold for only $93 million, which used to be $1 billion company one time, because of the cloud. That doesn't mean that Hadoop has gone away, but now Hadoop is on cloud as a service, managed service, not as something you have to build. You go in there, you can make it ready in 2 minutes. You don't need to do anything. You just click, your server is ready. Okay, 5 clicks and you are in, and wait for 2 minutes. You'll see that in Hadoop class, sorry, in AWS class, in 2 minutes you will build a MR cluster. Okay, so that's the reason these companies are still there wherever they are, but I don't think 5 years from now, I don't know how they will survive or not. Okay, all these companies, the data from this platform, now people are migrating to EMR or migrating to Databricks, migrating to cloud. The migration is going on pretty much every company. Okay. But technology is not changing. Technology is there. Whether you are on-prem or cloud, that is still there. That means this technology is differences. Now these are all on cloud instead of on-prem. That's the only difference. Okay. So this is the kind of history of Hadoop. And so okay. Any questions so far? So the next thing we'll learn is very basic called HDFS. Now that we know where it started from and all that, 2 main components we need to study is HDFS and MapReduce very briefly, so that we can go to, without learning those two, we cannot jump to Hive and Spark. Okay, I could have, my goal is to you guys to know these two, but how can you jump here without you knowing these two? That's the problem. Okay, without knowing these two frameworks upon which this platform is sitting, right, you cannot jump there. That's the reason we just need to know it, not to be expert on it, we know it so that we can understand what this is. Okay. Any question? So we'll very briefly, we'll talk about HDFS architecture today very quickly. As I said, you don't need to be expert on that, as long as you understand the concept. Same thing, understand the concept on MapReduce. Where we'll focus is a little bit on Hive and most on Spark. If you are going a cloud engineer, all you need to focus on is Spark. Okay, that's the only thing you need to know. But I cannot jump in there without you guys knowing a little bit of these two. And this will help. Cloud have a S3, all that blob store, same as HDFS. So if you know this, probably it will help you understand the other storage system on cloud as well. Okay. So HDFS. So if you are all good, we'll start with the HDFS very quickly. We talk about, as I said, I'm rushing through this thing because my goal is to get to Spark quickly, so that with with the knowledge of the underlying framework. Okay. Which are the two frameworks, HDFS and MapReduce. Although MapReduce is not heavily, they are not in use, understanding the architecture little bit will help how distributed processing works. Okay. HDFS, you will know why. If you are on EMR for whatever reason, on EMR is nothing but the Hadoop on cloud, AWS, you may have to deal with HDFS. If you don't know it, then it's a problem. So that's the reason we are learning also HDFS. Okay. Okay. So what is HDFS? Let's very quickly. You have 30 more minutes or 20 more minutes. Okay. We can continue tomorrow, HDFS, and then MapReduce. Then we'll go to Hive maybe on Thursday. Then on Spark on maybe Saturday. So that's something and we'll come back to all these technologies, not this one. We'll come back to Spark again and again later on. Okay. But this will just build your foundation. So HDFS stands for, as I said, it came from GFS, Google File System from Google, and it stands for Hadoop Distributed File System, right? Hadoop Distributed File System. Look at the name, distributed, and it's a file system. So that means it's something, what it means, it's some different kind of file system, right? Which is not a regular file system like Windows, Linux, Unix. These are a regular file system, but it's something different in here. One of the differences, it is distributed, right? That's why we see here. That's not typically what our Windows system is not distributed. If I'm putting a file in C drive, it's in C drive. It's not on D drive, or it's not somewhere else. It's in C drive. If I'm putting it in a folder, it's in that folder only. Of course, folders are more logical structures, but it's not jumping from C drive to D drive or right. It's one place only. It is there. Right? So it is, but here it is distributed and it's a file system. So how does it work? How do you make a file system distributed? That's the challenge, right? So if you have 1 terabyte file, tomorrow I have another 10 terabytes coming in. My system has few nodes, right? I'll come to that so in a little bit. So the challenge is, as I said, right? Where is it? Okay. So I'm not going to. These are written few years back, so I don't follow the same exactly, but you can look at it. This is the ecosystem we already talked about, right? HDFS, MapReduce, Pig, Hive, Zookeeper, all that's your ecosystem, part of ecosystem. Okay. On top of that, you can have a ETL tool, BI reporting. You can build your tools, applications on top, right? HDFS is a distributed fault-tolerant file system. Okay. I'm not talking about the rest of the stuff. And okay. So here is what I'm going to explain. Okay. So let's assume we have a Hadoop cluster. What does that mean? Cluster means combination of many servers or nodes together. Here, how many servers we have? 1, 2, 3. Think of 6 servers. 6 servers, and we call them nodes, 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 and there we call it a Hadoop cluster. Okay, it's not a regular server or regular servers. They're connected by the network and all that. We don't need to worry about all that stuff. Think of it's already built. You come in here. Hey, here is the Hadoop cluster, 6 node Hadoop cluster. It's a platform, one platform for storing your data and processing. You said, I put a file here. I put a file to that thing. What happens? What does the HDFS do behind the scene? Okay. So when you put a file, maybe 1 terabyte, 1 GB file, the file gets distributed into multiple servers. Instead of one single file sitting here in one server, one part goes here, another part goes here, another part goes here, and maybe 1, 2, 3, whatever it is, right? So the different parts gets distributed into different servers. That's the nature of HDFS. It takes the file, distributes it. Okay. So here is the thing. Okay. I say it takes the file, and then distributes it. You don't have to do it. It does it, right? What's the size? How big a piece it does? I mean, how big is its what you call slice? Okay. So the slice, each slice is typically called data block. So when you distribute it, it makes data blocks, right? and each data block could be size maybe 64 MB, megabyte, not kilobyte, or 128 megabyte, or even 256 megabyte. So this is the size, typical size. You can configure one or the other. So I say, hey, I'm putting 1 gigabyte file into this Hadoop cluster. You store it. As soon as you copy the file internally, HDFS will get active, and it will take your 1 gigabyte file, which is this, assuming this is the size, right? 1 meg, 1 GB, right? That many zeros. I'm just not putting 1.2.120.1024. Let's see, our data size is data block size is 64 meg. Divide by 64. 1, 2, 3, 4, 5, 6. How many? 15.6. So if I put a 1 GB file into a Hadoop cluster with a data block size of 64 meg, how many slices it will create? 15.6, maybe 16. So it creates 16 data blocks. It creates 1 GB file ends up as 16 data blocks. Okay. Assuming our size is 64. If it is 128, it will become 8, right? Then so it is breaking the file into 16 data blocks. That's the job of Hadoop. Okay, it does that. So it breaks. It creates this slices. Creates the data slices. That is not your job. You know, the framework will do it automatically. Then what do you do? Then it distributes these slices. Okay, distribute the slices. Where does it distribute? Based on how many nodes you have. Here I have 6. It will distribute maybe 2 put, it will put 2 here, 3 here, 5 here, 6 here. I don't know. Somehow it will distribute. I don't need to worry about that. So there is an algorithm behind the scene, how many will go where. Okay. So what node, what slice will go where, all that stuff is completely inbuilt in the framework. There are logic behind it. Okay. So that this slices among all nodes. Okay. Doesn't have to be among all nodes, by the way. Maybe there are 1,000. I cannot distribute 64 in 1,000. Maybe I'll put it, or 16 in 1,000. So depending on how big a file you are putting, right? Among the nodes, I would say, or in the cluster. Okay, in the cluster. Okay. How it does it? All that mechanism, principle, everything is controlled by framework. Okay. So I'm just telling you what the framework is doing. Okay. The framework capabilities. Okay. What is it doing? When you say framework task, what is doing? All that stuff it is doing, right? So that's what he's doing behind the scene. So in doing so, as a user, when I copy it, or developer, I say, hey, copy it from my mainframe to this. Internally, it is, you don't know, but it has taken your file and distributed among all this. So you don't even have no clue where is what. You have no clue which file is where. Think about it, it's not even, I'm not talking 6 servers here. It could be 20 servers, 100 servers, 1,000 servers. Okay. And they could be geographically distributed. Think about it. You have 2 data centers here in Dallas, maybe another in Charlotte. Your Hadoop cluster is across both the locations. So when you put a file, half of it is in Dallas, half of the over there. Maybe, I don't know. That can also happen. Or maybe somewhere in another continent. If you have data centers all over the world, think of AWS and Azure. They're all over the world. You don't know where your data is. So that is happening behind the scene. But as a user, am I worried? No. I don't know. I don't need to know where it is. But if I tell you, hey, show me the file, it will, within a second, it will give you, a second or minute, whatever it is, it will give you all the file back to you. So it will collect the information from all the servers, wherever it is, give you the file back. Whether you are doing a show file or you are doing some data processing behind the scene, everything is completely automated. Okay. So how does HDFS do that? Okay, to understand that, you need to understand the architecture. So here is the architecture. So here is the architecture of a typical Hadoop cluster where we have 5 nodes here, 1, 2, 3, 4, 5. and there is something. So 6 node cluster. One is at the top, another 5 are here. It could be 5 node, it could be 100, it could be 1000. But the architecture is this is how it works. Okay. So there are two major components of the architecture you see here: name node and data node, right? So architecture. So two components: name node, data node. Okay. So two major components of it. But before that, what do you see it looks like? There's one master at the top, and there are many slaves at the bottom, right? Which we call master slave architecture or parent child architecture. There's one master controlling the rest, right? So this is we call it master slave architecture or parent child architecture. Okay, we call it. So you'll see this kind of architecture everywhere in most of the distributed platform. There will be master, and there will be a lot of these things will be managed by this master. So here, one of the servers is your master. That's your master. Which what it does, it manages. That's its work. It manages the cluster. All the rest of the nodes, that's its job. Nothing else. That's what it does. What does data node do then? It stores the data. This is where the actual data resides. And name node controls these data nodes. So you think of this as a cluster. 6 nodes, one of them is name node, rest are all data nodes. Now you copy the data. So you don't know where it will go, which data node it will go, how it will go distributed. Who is doing it? Name node. Name node is making it happen. Okay. And this is all the 6 data nodes or 6 nodes are connected through a network. As you see here, they are all connected. They talk to each other. Okay. So when you install your Hadoop, basically you're installing a framework, configuring it, and it's a living, breathing system running every second. They're talking to each other, they're pinging each other and saying, right, making sure the system is all alive, no node is down, no hardware failure has happened, no software failure, nothing, no memory failure has happened, right? System, because everything is separate, right? Each one is a separate server. So that is taken care by the name node. Okay. So what happens in real situation? You copy a file. So again, we talked about this. So manages the server, and there is architecture. There is something called there is a network. Of course, they are all talking to each other, and there is something called communication, right? Communication between the nodes, right? Which we call it kind of heartbeat communication. It's like a pinging. Are you alive? Are you alive? Every 2 seconds, I'll say, hey, are you alive? Are you alive? Are you alive? Are you alive? That's the kind of, think of a network level, just pinging. Okay, are you okay? Are you okay? Are you okay? That's the kind of work. That's the pinging happening I don't know, whatever the time frame is, right? Every time name node is checking on each data node. But data nodes are actually telling the name, hey, I'm alive, I'm alive. So if it doesn't hear from any of the data node for some time, it will understand that something has gone wrong. Okay, so it will say, okay, this is a dead node now because I'm not responding, it's not responding anymore. Okay, so it will automatically know, and it will try to recover the data from this. Okay, how it will recover, we'll talk about that. Okay, so there's network communication, and there is something new thing. So as you say, what happens if this data node goes away? You lose this data, right? Earlier you saw one slice of data is here, one slice of data is here, one slice of data. So what happens if one slice is gone? Your file becomes unusable, right? If 1 megabyte out of a 1 terabyte is gone, whole terabyte becomes unusable, right? Because file is not complete anymore. So what happens? So here with this data node goes away. It was storing one part of your 1 gigabyte file. Data is gone, right? So you could lose the data, any piece of data anytime. It can happen. Hardware failure can happen anytime. So what will it do? So to recover from this kind of situation, what it does, there is something called replication. It's part of the architecture. That means every data block you create, you make another 2 copies of it. You know, here we thought of 16 copies, or sorry, 16 data blocks. It doesn't create 16, it creates 16 multiplied by 3, 48. 48 copies or 2 additional copies, and distribute the 48 copies, not 16 copies or 16 slices, 64 copies, not 64, sorry, 48 copies in all these data nodes. Now you may think, hey, why so much of redundancy? Unnecessarily, I'm storing 2 additional copies. That means if I'm storing 1 petabyte, you are storing 3 petabytes of 2 petabytes additional storage. Yes, that's what it does. But think about it. Storage is cheap, right? You are using commodity hardware. We are not buying 100K per terabyte kind of storage. We are storing storage is $500 per terabyte. That's okay. We can afford the 2 additional copies. Even then, it will be cheaper than other systems. Even then, it will be cheaper. So it creates the multiple copies to avoid data loss. Okay, to avoid that data loss. If one node is gone, your file becomes completely unusable. To avoid that situation, it does something called replication. By default, the factor of replication is 3. Factor of 3. That means every slice has 2 additional copies. So what happens? So if this one goes away, there is a copy here. See the color scheme here, this yellow or whatever, or orange. You have 1 copy here, 1 copy here. Black has 1 copy here, 1 copy here, and blue or whatever that thing have 1 copy here, 1 copy here. So it does not keep all the copies at one place. It automatically distributes the copies in another node, so that in case of failure, you have a copy somewhere else. Okay. So chances of 3 copies going out same time is very, very rare. One server can go down, another server can go down for whatever reason, but going 3 copies going out same time is very rare. So 3 is the best safe number, right? So typically we use 3. In case of one server going away for whatever reason, hardware failure, memory failure, network failure, electric power failure in the data center, immediately the name node or the framework has a copy somewhere here. Whichever copies are lost, it starts rebuilding those copies somewhere else. Okay, immediately rebuilds it so that it comes back to 3 again, because now you are lost, become 3 to become 2, right? 2 copies. So it rebuilds those copies somewhere else, wherever the space is available. Okay, so that is completely automatic. User doesn't need to know. Not only that, if you are processing something in the middle of processing, running a query, Hive query, in the middle, this node goes away. It's unusable. In the processing, during the processing, it will automatically detect the failure. It will redirect some to somewhere else and start processing there. Okay, so it's completely automatic, unless something really fatal happens. Otherwise, user will not see any difference. It will all completely managed by the framework. That's why I called it, right? It's a living, breathing platform, so that user doesn't need any, it doesn't see any anything happening. So it's all under the cover. Okay, that's why it's very robust, by the way. So those are some of the principles or characteristics of HDFS. There is a name node which manages the rest of the node. There are data nodes, many data nodes, one or many, which stores the data. And there is network communication between all those things. And one of the main things is called replication, so that your data, if you lose one node, your data blocks can be restored in other nodes because you have copies. Okay, this is how distributed storage works. Now, if my data is full, this cluster becomes full. What do I do? All I need to do is add 3 more, 10 more nodes here, 5 more nodes. As soon as I connect to the network, install the software, configure it, automatically my storage goes from 1 terabyte to maybe double it to 2 terabyte. In fact, automatically the data gets distributed to the other nodes automatically. You don't need to do that. That's why you see it as balancing. Rebalancing happens automatically. Replications happens automatically. These are all inbuilt characteristics of this framework. Okay, these are inbuilt characteristics of the framework. You don't need to do anything from the user or developer standpoint. Okay, any questions from the framework standpoint? How it works? Name node, data node, these are some of the things you just remember, just in case, because you are learning new technology. Name node, data node, and data block. Size of the data block is typically 64 meg, 128 meg, and there is something called replication. These are the minimum things you just need to know. Okay. Other thing we'll touch upon tomorrow is how do I get to the platform and do some look at those file system. Okay. So this is where I'll give you today. I'll share some virtual machine, which is a Hadoop virtual machine. You can install on your laptop because we are not on cloud yet. Okay, this is a local machine. You can install in your virtual machine or install on your local what you call on your laptop, just like I'm running now. So this will give you a local instance of Hadoop. Okay, to practice Hive, to practice Spark, to practice all those. Okay, then we'll go to cloud. This will be all on cloud anyway. There you don't need to install anything. So tomorrow, first 1 hour, we'll do quick practice of Hadoop. Quick practice of Hadoop, so that you can do practice. What practice you will do? Things like, oh, how do I list out my files? If you, that's why I was asking the first class, do you know Linux? Right? So we'll learn some commands like files, Hadoop, file system commands. If you know Linux, they're pretty simple. Like ls, I'll list the file. Okay. I'll create a directory, mkdir. Oh, I want to remove a directory, rmdir, remove directory. Okay. I want to open a file called cat. Right, there's cat. So these are some of the, there are around 20 commands which you need to be aware of. Okay, listing the file. If I'm on a Hadoop platform, I need to know how to navigate in the platform. Otherwise, I will do my work. Right, some basic thing. Again, on Hadoop on AWS world, maybe you don't need to get inside that, but who knows? You may end up doing some command line stuff. We don't know, right? So that's why it's better to know it. Okay, so some of the commands we'll practice, and you can do the practice yourself on the platform. Couple of weeks of practice, maybe you will get better at it, right? RM, remove a file. Okay. So some of the commands, typical file system commands in a Linux, and the Hadoop commands are pretty similar as Linux, with a little bit difference. I will tell you tomorrow. Okay. So since it is a parallel operating system, not operating file system, on top of Linux, see, it's still starting, but tomorrow we'll see that. So we'll log into the Hadoop platform tomorrow. If you know Linux, you can do your regular ls, this, that, change file, cd command, this, that. Also, you'll learn how to do Hadoop commands. If I'm looking at a Hadoop file, how do I do that? Because Hadoop file is different from a regular Linux file. What different it is, right? Think of your file is data is coming from mainframe as a Linux regular file. What do you do? Oh, I want to convert to HDFS. How do you do that? Okay. So those kind of stuff you will learn those commands tomorrow, very basic, so that you get started with the Hadoop platform. You know how to deal with files. That's very first thing. Okay. Then tomorrow, second half, we'll talk about very basic concept of MapReduce. That should be sufficient. Then on the Wednesday or Thursday, we'll get into some Hive and Saturday, we'll completely 4 hours, we'll talk about Spark. Okay, so I know it's a little bit fast paced, but our goal is to learn Spark. That's our goal. But unfortunately, I cannot jump there without you knowing what is HDFS. Okay, or knowing a little bit of Hive, because I feel you guys need to know a little bit of Hive. Okay, so that's where we are at. What's any questions? Otherwise, we can end for the day and we'll meet tomorrow. We'll look at some actual lab of HDFS and share the Hadoop platform today. It's a large software, 17 GB gigabyte. You can download from my Google Drive. Send you instruction, you can install it. There you can practice simple HDFS commands. Practice your MapReduce, not MapReduce. We are not doing all those stuff. Little bit Hive, and eventually you will practice Spark here. So that when you go to AWS or any cloud environment, you can. It's the same thing over there. Only thing is that it's managed. Difference is here we are building it. There you don't have to build. That's the only difference. Okay, but same command, same skill set will be used there. Okay. Any questions?
Ritika, there is one question. In the architecture diagram that you were showing, right? HDFS, there, like you have the name node, right? If the name node goes down, what is the backup? I mean, that backup node does it.
Yeah. Maybe I missed it because I'm running at 100 miles per hour. So okay, so you don't need to. In some of the things, I'm trying to skip whatever you don't need to know. Anyway, that's actually anyway. So backup. So name node, as you correctly said, rightly said, name node is the critical node here. What we call, see, if the data node goes away, we have a backup because the replication is there, right? If name node goes, your brain goes away. If the man's head is gone, you cannot survive. If your hand is gone, you can survive, right? So your brain is gone. So that's why name node has a backup. This is like what we call the SPOC, single point of failure, SPOF. For that reason, name node always have a backup. So when Hadoop 1.0 came during 2012-10, they come up with a backup node. If over the years it has changed. Now we don't go for a backup as such. We call it hydrated name node. The new architecture, you don't need to know a lot on that, but think of there are some other arrangements nowadays. It's a failover which is high availability failover. That means there will be two name nodes here. One name node here, one name node goes away, immediately other one picks up. Automatically it senses. Within seconds it will pick up the second one. See, what does it do anyway? Name node, it manages. One thing I have not talked about is the name node also stores the information about the data node. That means what file is where, what data block is where, all that is stored in the name node. So you lose your name node, you lose that information. When you lose that information, your whole cluster becomes unusable because you don't know which block is where at this point. You have no clue how to assemble it together back again to a file. So that's what you lose. For that reason, the new platform Hadoop 2.0, which after came 2012, 13, all that stuff, right? They have something called HA failover, high availability failover. You don't need to know it to go into the details, but assume that name node has backup. Some way it does backup. You don't need to go into that. Those are more about administration capabilities. We are not getting into administration, but yes, there are backups. Either offline backup like backup node or HA failover is the advanced way of doing it. Completely, typically, unless you become a Hadoop administrator, you don't need to know all of which we don't. This course is not for admin. This is more for data engineer. So we are kind of just know it. Yes, there is some backup. Okay.
So this the switching will it's like a automatic, right? Suppose if this goes.
Yeah, it's automatic. HA might have whatever high availability.
High availability.
Right? HA is very common everywhere. Even application server, everywhere wherever multiple nodes, the switching can happen automatically. And there are HA softwares behind the scene. The software will be installed. Basically, those two name nodes will be pinging each other every time. Okay, are you alive? Are you alive? So there will be active, there will be passive one. So passive one will be pinging active one. Are you okay? Are you okay? Are you okay? If it doesn't hear for a second, oh man, it's gone. Let me take it over. So immediately takes it over. So user will not see the difference. Okay, this HA failover is that's how it works. So it's a new, not a new concept, but this has brought in the concept to maintain the name node what do you call failure, so they can get over that failure as well. Okay, but for data node we don't need HA because one name node data node goes okay, no problem. I have copies here, no worries. I have 2 copies here and somewhere else. I can rebuild it. Okay. Any other questions? All right. So what we learned today is basically the history of Hadoop, right? How we started from mainframe to relational database to appliances to big data to cloud. This is our journey, right? This is how we have been doing last 20, 30 years, pretty much. And what is the role of Hadoop? When did it start? Around 2010, 12. What are the ecosystem products, components? And we started with first component called the HDFS because that's where the storage. Then we talk about the processing tomorrow. Then we talk about the database. Then we go to another processing framework called Spark. Many other components are there, Kafka, this, that. We are not getting all the stuff. Those things you will focus on cloud mostly. We are not getting into all the stuff.